boundary of life. If there is any area you are interested in, we call this as a system. And except this system, outside of a system is called as environment. Now, there is dividing area, so-called boundary area we can define. Here, the system you can define arbitrarily, so that means maybe this environment can be your system, then this enclosed area can be environment. In physics, the systems can be divided into three different kinds of classes. If the material or matter and energy cannot in and out of the system, then this kind of a system is called as isolated system. Now, if the system allows energy in and out, but does not allow the matter in and out, this system is called as closed system. So that means closed system is a little more open system comparing to isolated system, but it is closed to matter entry, but it allows the energy in and out. Now, more open system is allows both matter and energy in and out. Let's think about the life system. If life has boundary and life allows the energy in and out, also life allows the matter in and out. That implies that the life is kind of an open system, but this is a very well controlled the in and out, not random in and out. The important point is life form should have order inside the system. Life should have well-organized structure, also well-maintained the function. That's how it can keep the order inside the life systems. Order and entropy has the opposite meaning. Entropy, in simple terms, it can be considered as degree of disorder. So that means high order is low entropy, low order is high entropy. Even inside the life systems, entropy always increases. That's why to keep the order inside life system, we need to pump out the entropy to the environment. But this process is not free. Always we need to have input energy to remove extra entropies. The high quality energy source here is from sunlight. Well, you may think life form can do metabolism, and maybe we can obtain this energy from nutrient, and through metabolism, by removing the waste, we can get this energy, you may think. But if you think one more step, all the nutrients in our planet system, those are organic molecules. Eventually, those molecules are from sunlight. Now, let's think about the boundary material of life. All the life forms, we exist in the environment of water or aqueous media. Now, to isolate ourselves, the life system area from environment, maybe it's better to use the water immiscible material. Most representative water immiscible material is oil. Either big or small are the oil drops. If you use, we wanted to isolate maybe the life space from environment, but the problem is these fully oily materials, if you put into the water, they are fully phase separated, and then oil layer and water layer is formed. So that's why to maintain the boundary space, this oily material should have partially hydrophobic area in the middle and both sides of a surface should be hydrophilic. Then they can contact water environment and they can maintain itself. Well, current life forms we have two-tail lipid structure, but maybe simpler structure would be single tail and carboxylate head group. This may be simple carboxyl acid, and this may be the first the material which has been used by life forms, we can think. In water environment, if there is any oil drops, and if you add this kind of a long chain carboxyl acid, then they can form this kind of surrounded the structure. Now, the hydrophobic area can form this inside material, and outside is hydrophilic head groups is formed. So to summarize, if in water environment, if there is oil drop, then carboxylate circulate these oil drops and make it soluble in water environment. This is the principle of soap, isn't it? Soap material, which has hydrophobic area and also hydrophilic area together. Now, hydrophobic area surround the oil drop and hydrophilic area the face outside, and they make this oily material soluble in aqueous media. This kind of structure we call micelle. In opposite way, in the middle of oily environment, if there is a water drop inside and carboxyl acid, now interestingly, hydrophilic area can face this oil drop, and then hydrophobic tails face outside and are located to the oily environment. And this is kind of a reversed form of this micelle. That's why this kind of a structure we call reverse micelle. Now, if we have long enough fatty acid structure, now they can make this kind of a bilayer. Inside is this kind of a hydrophobic area, and outside is a hydrophilic area like this. Then this can form this kind of a liposome structure. Here, inside, outside, both of them are aqueous media. And as you can see here, only the boundary structure is hydrophobic, but those are the contacting surface, and also both the space is a water environment. Now it's ready to have the life structures inside this liposome. This is a soap bubble. The material of soap bubble boundary is also fatty acid. Only difference is this is not in the water, this is in the air. Inside this bubble, outside of this bubble, both sides are air, right? Then, can you guess the structure of the soap bubble boundary? Is that single layer of carboxyl acid or double layer? Also, is that the similar to the micelle or reverse micelle? What do you think?